Assalamualaikum and good morning to Doctor and all my fellow friends. So today we are from group 2. We'll present about the topic of zeolites. But before that, here is our group member. So I will start with the introduction of zeolites. What is zeolites? Zeolites are microporous solid with crystalline structure. They are commonly referred as alumina silicates because it is formed from the interlinked tetrahedra alumina and silica, which form cages connected by pores of an opening of defined size, and the size is depending on the structural type of zeolites. Okay, so basically, if you can see from the left part here, is the structure of zeolites. The blue one is the sodalite cage or the beta cage. The zeolites is composed of 8 beta cage, which are linked together in cubic pattern with the central cavity called alpha cage or a super cage, where the water or other small molecules can fill and diffuse inside the super cage through octagonal faces. But if you can see here, this octagonal faces is too small, so it cannot permit any big molecule with a bigger or larger van der Waals diameter. And if you can see here, the purple color is the cation site, where the function of this cation is to neutralize the positive charge inside or on this lattice.
Okay, next I will present about the zeolite chemistry. Zeolites are hydrated aluminum silicate minerals made from interlinked tetrahedra of alumina and silica. In simple words, they are solids with relatively open 3D crystal structure from the elements of aluminium, oxygen, and silicon, with alkali and alkali of metals such as sodium, potassium, and magnesium, plus water trapped in the gaps between them. Zeolite can form with many different crystallized structures which have large open pores, sometimes referred as cavities, and very regular arrangement and roughly the same size as small molecules. And this is the general chemical composition of zeolite, where N is the cation, such as Na+, K+, and Li+, and N is the charge of the metal cation.
There are many properties of zeolites. For the first ones, the zeolite is a good absorbent. This property is usually used in the purification of the water, that it can absorb many molecules like waters, ammonia, carbon dioxide, and many other molecules. So this also can be exploited in the enhancement of the formation of the sludge, which is based on the adherence of bacteria to small zeolite rock grains. So the example of these properties is used in the treatment of the drinking water with the presence of the zeolite. For the second properties is the ion exchangers. This also usually used in the purification of the water, like the previous properties. So the exchangeable of the zeolite surface ions can be replaced by the ions from the solution. Like the ions can be a sodium, a silver ions, and the example of the solution can be water molecule. So this zeolite also can be function as the Bronsted acid in a catalytic reaction, which enable in the catalytic process, which this Bronsted acid is tendency to transport the proton.
So next, I will continue with types of zeolites. There are two types of zeolite, which are natural zeolite and also synthetic zeolite. For natural zeolite, as come from the word naturals, it is made from the processes of natural ore bodies, which occur naturally. And it needs to be more acid-resistant silica to hold its structure together. As we know that the pH of soil,
water in our environment keep fluctuating. Next is synthetic zeolites, which manufactured from energy-consuming chemicals, and it can also be engineered with a wide variety of chemical properties and pore size. Synthetic zeolites usually have greater thermal stability. How do we synthesize zeolites? So usually we synthesize zeolites in liquid phase since it is easier compared to solid phase. So in liquid phase, we have these three methods. The first one is solvothermal method, which use of solvents, which range from non-polar and hydrophobic solvent to polar and hydrophilic solvents. There are few solvents that had been used successfully to synthesize zeolite, for example, alcohol, pyridine, and also hydrocarbons. The second method is hydrothermal method, where the word hydro means water, so we use water as solvents, and it also needs basic environments. The temperature range from 90 degrees to 180 degrees Celsius with the hydrothermal synthesis pressure inside a Teflon lined autoclave. The third method is by using ionothermal method, which use of ionic liquid. And we know that ionic liquid has low vapor pressure, and also it is also a green solvent. So it is actually a good substituents to solvents that are harmful and carcinogenic. This hydrothermal method and ionothermal method can also be classified under the solvothermal method. This is the Teflon line autoclave diagram, which is used in hydrothermal method.
Thank you, Zakia. Now I will proceed to the application of zeolites. To be specific, it's selective absorbance and drying agent. There are 3 points in this presentation. But the first point is about the glyphosate treatment containing water and wastewater. Glyphosate is an organophosphorus pesticide which is a threat to human and environment because it can interfere with the function of nervous and endocrine system. Thus, zeolite 4A is used and modified by cation exchange with cupric ion. For the second point is about the volatile organic compound absorption. Potasite is an example of natural zeolite, and it can access to a wide range of molecular size and can ensure the good absorption capacity. ZSM5 zeolite is an example for synthetic zeolite, and its performance is better for a smaller volatile organic compound molecule. The figure below shown here is comparing between the pore size. For potasite, it has a larger pore size than ZSM5 zeolite. For the last point is about natural zeolite as the hydrating agent. Here it uses a zeolite A and philipsite, which has a similar system channel with a 3D system channel. NAA is selectively stops for water molecule and a better absorption for hydrocarbon with linear chain structure, and its free pore volume is 50% larger than philipsite. That's all for my part. Thank you. Here is the references for our slide. Thank you.
Let's watch this video. Come on.
The most interesting about zeolite is their open case structure. This allows zeolite to trap other molecules inside it. Zeolite have its opening in them, which let small molecules pass through but trap larger molecules. For this reason, they are sometimes referred to as molecular sieves. Natural zeolites appear in random forms and with sizes. However, zeolite can be synthesized in very precise and uniform dimensions to trap certain size of molecule inside.
For the application of the zeolites, in this video, the zeolites are used to purify the air from the mixture of nitrogen and oxygen. The mechanism proposed is the nitrogen will be filtered by the zeolites by staying outside of the pores, and only oxygen will pass through the zeolites' pores. This pore indicates that the zeolites are very selective toward the size of molecule. Furthermore, since zeolites didn't use any chemical, thus we can assume that the oxygen are safely purified and safe to consume by human beings.